The primary focus of this lesson will be on the formed intercept spacer as it exits the cutoff station. Here, we will inspect the form of the finished spacer to the specification outlined in GED document ES-0008.
ES-0008 illustrates various spacer dimensions for tinplate and ultra stainless steel spacers. The nominal spacer width is what the spacer should measure across the bottom of the spacer. The actual measured width should be within plus or minus 5/1000ths of the nominal value. Splay is the difference in measured spacer width across the top of the spacer compared to the measured width across the bottom, as measured at least 3 inches from corner or muntin punches. ES-0008 states splay should be no more than 5/1000ths wider or 20/1000ths narrower at the top versus at the bottom. A slight bit of negative splay is typically desirable, as it may negate the effects of flare issues. Slight negative splay will also tend to push sealant up the sides of the spacer when pressed, improving the wet out. As a general rule, 5 to 10/1000ths negative splay is desired. Splay, however, is very difficult to measure consistently with calipers. The GED Splay Gauge is more accurate and consistent as shown here. Measure the width across the bottom, zero the gauge, and measure across the top. The height of the sides of the standard profile spacer are 300/1000ths with a tolerance of plus or minus 5/1000ths. The top lips should be 78/1000ths plus or minus 5/1000ths, but more importantly, they should be nearly equal. If the top lips are not equal, this may cause a side bow or twist in the spacer due to the asymmetric formation of the spacer. It may also impact the corner wrap, affecting how the corners fold. Corner wrap will be discussed shortly. The height and width of the folded frame should be within plus or minus 32/1000ths of an inch of the specified nominal dimensions. Keep in mind the IG unit configuration file that is being used. Several values used in a typical configuration file will affect the overall height and width of the spacer frame. Refer to the user's guide for more information on IG unit settings. The tab or leading edge of the spacer is the same width as the spacer when it exits the roll former. In order for the tab to insert easily into the end of the spacer, the tab must be swaged 25 to 35/1000ths narrower than the measured spacer width. If the tab width is too wide, it will cause excessive flare at the fourth corner, and excessive handling damage may occur to the sealant due to the extra force required to push the tab in. If the tab width is too narrow, it may fall out while hanging on the overhead conveyor. Swaging is one of the functions the cutoff station performs. Another function of the cutoff is to separate the individual spacers at the parting location. The parting area is slightly wider than the cutoff blade, so ideally there should be a little bit of the parting area left on each end of the spacer. If the cutoff location varies from spacer to spacer, then inspect the pacer encoder wheel that rolls on the underside of the spacer between the roll former and the cutoff. Verify the wheel is clean without gouges or damage to the surface, and the spring tension is adequate enough to prevent slippage. If the cutoff location is incorrect but consistent, then have a qualified maintenance technician adjust the cutoff parameter in the machine constants. Follow lockout-tagout procedures when cleaning the pacer encoder wheel. Corner flare occurs naturally as the spacer is roll-formed because material has been removed by the corner dies. Since this material is missing, there is not continuous support on the sides as they are formed around the corners. As a result, the material at the leading part of the corner springs out slightly, while the trailing part of the corner remains inward as shown here. Per ES-0008, corner flare should not exceed 5 thousandths per side, as this reduces the sealant thickness between the glass and the spacer when the unit is heated and pressed. While some corner flare can be controlled in the roll former setup, adjusting the crimp pins in the crimper provides better control. Use the splay gauge to measure the corner flare in order to determine how to adjust the crimp pins. Reference GED document APN 0187 for proper use of the quality gauges. Corner flare may also result from folding the spacers and bending the corners past 90 degrees. Overbending the corners will cause the corners to flare outward. To avoid overbending the corners, always keep the corner greater than 90 degrees until the tab is inserted into the tail end of the spacer. Overbending will cause the corners to deform and flare out. The effects are not easily noticed because of the sealant on the spacer, but once through the oven and roll press, the metal can often be seen against the glass. The inevitable result will be a failed unit. Corner flare may also be a result of twisting the corners by not folding directly over the belt as shown here. Ideally, you want to fold spacers in a plane perpendicular to the extruder belt. This is often the issue in folding large spacers. To prevent this, it is recommended that two operators fold larger spacers. Corner protrusion is a type of corner flare caused by a shallow corner punch depth as measured from the edge of the material to the top of the web area. This dimension is typically around 222 thousandths. As this dimension is decreased, the bottom of the corner will start to protrude outward on the sides of the spacer frame. This point or protrusion creates a stress point, which can lead to a stress crack in a finished IGU, either when the unit is pressed or over time. Corners that are punched too deep will exhibit the protrusion on the back of the spacer. This is typically not an issue. However, improper punch depth, particularly on ultra stainless steel spacers, may cause the corners to fold improperly. Any type of corner flare, twist, or protrusion should not exceed 5 thousandths per side. Corner gap and corner protrusion go hand in hand, as they are both a result of a shallow corner punch. By design, there is to be a minimum of a 23 thousandths gap in the corner when the corner is folded to 90 degrees. Too little of a gap could break the web in the corner, which is an integral part of the seal. If the web breaks, it creates a short moisture path, or MVT, which stands for moisture vapor transmittance. As illustrated here, normally for moisture vapor to get into the unit, it has to permeate the entire side seal or permeate the sealant in the web area. A broken web will create a very short moisture vapor barrier, which will allow moisture to enter the unit easily. The web may also be broken if a corner is folded, unfolded, and then refolded as shown here. The damage in this case is usually not visible until the unit fails prematurely in the field. The other issue in the folding method shown here is that the side seals may pick up fibers from your clothes, which can act as a wick to allow moisture to enter the unit. You should avoid touching or contacting the side sealant against anything to avoid contamination. The corner web may also be broken due to backbending, which is a result of allowing the spacer to bend backwards, breaking the web. Bending a corner backwards ever so slightly will cause the web to break. When folded, the web often overlaps the side of the spacer, but may be undetectable under sealant. Once pressed out, however, the damage may be clearly visible, but not always. If the broken web folds inward, the damage will not be visible. The integrity of the seal, however, has been compromised. In addition to shortening the moisture path, backbending and breaking the web often results in part of the broken web overlapping the sides of the spacer, which reduces the sealant thickness between the glass and spacer when heated and pressed. It also creates a stress point that may result in stress cracks in the glass. In either case, the result is typically a prematurely failed IG unit. How deep the web impression is embossed affects the quality of the folded corner. If the impression is too shallow, the corner will fold more difficultly and may flare, distort, or bend outward. If the impression is too deep, the web may break when folded or even be completely cut out like a cookie cutter. Embossing too deep is a result of hitting too hard, which may damage the dies or decrease the life of the die. Typically, the tip of the corner web should be somewhere in the middle of the bottom radius of the spacer. A corner punch of 222 thousandths should put the point of the web in a good location for proper corner folding, as seen in the image on the left. Improper corner punch depth or variance in roll forming dimensions may require adjustments to the corner punch depth in order to get the corners to fold correctly. The image on the right shows a web impression that is too high. The tip of the web is at the top of the bottom radius, which will likely result in corner protrusion, insufficient corner gap, and possibly improper folding of the corners. While bow, twist, and splay are typically controlled in the roll former, they are often included into the spacer from other influences. It's important to identify these issues, but it's more important to find the root cause. In other words, before adjusting the roll former, check to see what else may be causing the issue. Below are a few things to check which may be causing the deformity. Side bow is typically a result of pushing harder on one side of the spacer than on the opposite side. Side bow should not exceed 20 thousandths per foot or 64 thousandths over 4 feet. Up or down bow should not exceed 20 thousandths per foot or 93 thousandths over 4 feet. Twist in a formed spacer should not exceed 15 thousandths over 4 feet. Twist often results from not doing the same thing at the same time to both sides of the spacer. Side bow and twist often appear together.
Thank you for participating in this lesson on Formed Intercept Spacer quality checks. Please continue with the next lesson on Extruded Intercept Spacer quality checks. When you have completed the 3 lessons in this Finished Spacer Quality Checks section, please continue the lesson on Intercept Spacer folding techniques.